Hello everyone, welcome to Wrath of Math. I'm your host, Sean E, and in today's video, we're going to be looking at how to derive the distance formula using the Pythagorean Theorem. This is basically a proof for the distance formula that relies on the Pythagorean Theorem. So let's say we have a coordinate plane, and we've got 2 points on this plane. They could be anywhere, doesn't really matter. Let's say we have one here and one here just to make things look interesting, even though it doesn't really change anything. And let's say that this point has coordinates x1, y1. Keep it generic because we're effectively writing a proof, so we need to make sure that we don't set any restrictions on the points. They can just be any generic x and y values. x2, y2. And again, we're assuming the Pythagorean theorem is true. We know it is in Euclidean geometry, so we use that for this proof. So we construct a triangle by connecting the 2 points directly. I know that's a pretty crappy line. And then extending lines from the points so that they intersect perpendicularly, creating a right triangle. And whether we were to draw this right triangle or the one that would emerge from connecting the lines this way, it doesn't matter at all. So we'll just say we're looking at this triangle just so you get an idea of what we're doing. Now, we're going to use the Pythagorean theorem to figure out what this hypotenuse length is because, of course, the hypotenuse is the distance between these 2 points, and it would look like it as well if it were a slightly better drawing. So what is the distance, or rather the length, of this side? Well, it's self-evident that the length of this side is x1 minus x2. And we know that. We don't need to use a distance formula for that. It's like just looking on a number line and asking, what's the difference between 2 and 5? Well, it's just 5 minus 2, which is 3. So it's just x1 minus x2. So we know that the length of this side, we're going to try to build an equation using the Pythagorean theorem here. So we know the length of this side is x1 minus x2. And this is the first leg of a right triangle. We're going to square it because we're using the Pythagorean theorem. And to this, we add the length of this side, which again, it's self-evident. It's y1 minus y2. It's a vertical line. It could just as well be a number line. So we add to this y1 minus y2. And we square that. And remember, we're using the Pythagorean theorem here, so we're writing an equation of the form a squared plus b squared equals c squared, where c squared is the square of the length of the hypotenuse of a right triangle, b squared is the square of the length of a leg of a right triangle, and a squared is the square of the length of the other leg of the right triangle. So these are the squares of the lengths of the 2 legs of our right triangle. And by the Pythagorean theorem, we know that the sum of these 2 quantities is equal to the square of the length of this hypotenuse, and we will just call it, let's call it z. So z is the length of the hypotenuse. So we know that this is equal to z squared. Actually, if I could rewind, I'd call it d, but I already went with z, so let's go with z. So we know that z squared is equal to this. Well, we're trying to solve for distance, which is the length of the hypotenuse, so we're trying to solve for z, so all we need to do is take the square root of both sides. So we get z equals the square root, write this stuff out, x1 minus x2. This is the square of the length of one side of the right triangle. And then y1 minus y2, this is the square of the length of the other side. And we extend our radical, and then we are left with the distance formula as desired. Z, which is the distance between the 2 points, is equal to the square root of the square of the differences of the x and y coordinates of the points. And when you use the distance formula, because you're squaring this difference, the order of the points doesn't matter. You could do x1 minus x2 here and y2 minus y1 here. So it's not like the slope formula in that respect. The order does not matter. You just have to keep your x's with your x's and your y's with your y's. And so that is how you can prove the distance formula using the Pythagorean theorem. Pretty short proof, only a couple steps, but I hope that helped you understand the distance formula and understand how it relates to the Pythagorean theorem. It's basically a direct result. So I hope you enjoy the video. I hope it helped. Let me know if you need anything clarified or have any other questions you would like answered in the comments. Thanks a lot for watching. Be sure to subscribe for the swankiest math videos on the internet.
I can hear your voice from all the way up here, dear. Won't you please come to me? You love it up here, dear. There's a light where I float that erases all